combination reactions are easy to recognize because a combination reaction will always have, for this course, just two elements. Aluminum is an element and chlorine is an element. There are no compounds over here. They're each just single elements. A combination reaction means those two elements will react to form a single compound. So when predicting the products of a combination reaction, the first step is to write the symbols next to each other. So I'm going to write aluminum and chlorine because those are two elements. Since one of these is a metal, aluminum is a metal, and chlorine is a nonmetal, that means this is an ionic compound. Since it's an ionic compound, we need to make sure that the charges of this cancel so that the compound can be neutral. Aluminum is a 3+, chlorine is 1-, which you find those numbers on the periodic table. So we need 3 chlorines to cancel out our 1 aluminum. So I'm just going to rewrite that. Keep it all nice and neat. So aluminum chloride is like this, is our product. So that's our product, and then we can go back and balance the equation. Since we have chlorine has 3 here and 2 here, if they have one is even and one is odd, you can just switch those. So this 2 over here from chlorine we'll put in front of the aluminum chloride, and the 3 from the chlorine there we'll put in front of the chlorine here. Now we have 2 aluminums here and 1 aluminum here, so we'll put 2 aluminums here. Okay, let's try our next example. So we're going to react magnesium with nitrogen. Again, you can see that this is a combination reaction because we have 2 single elements. We just have magnesium, which is an element, and nitrogen, which is an element. And these will combine together to form a single compound. So we'll write the symbols next to each other. Since magnesium is metal and nitrogen is a nonmetal, it's an ionic compound. So we need to look at the charges and make sure that they balance. You don't have to memorize these charges, but you can find them on the periodic table. Okay, so magnesium is 2+, nitrogen is 3-. When one is even and one is odd, we just switch them. We'll take the 3 down here, and we'll put the 2 here. Okay, let me clean that up. So we have magnesium nitride, 3 magnesiums for every 2 nitrogen. So magnesium nitride. So we can go back and balance the whole equation. We have 2 nitrogens here and 2 nitrogens here. So that already balances. And we have 3 magnesiums here, but only 1 on this side. So we'll need to put a 3 over here as a coefficient. Now it's a really common mistake to want to look at an equation like this. Let's look at the aluminum one. Aluminum plus chlorine, and write the reaction product as aluminum chloride, like this with a 2. But that is not electrically neutral because aluminum has 3+ and chlorine is 1-. And so this compound would have a positive charge overall, which is not stable. And so aluminum chloride needs to be written like this. So that's why when we're done writing the product, you always write the product first and then go back and balance the equation with these coefficients. Let's look at one more example. Let's react lithium with oxygen. These reactions where we react a metal with an oxygen are extremely common. So we're going to follow the same procedure that we followed before. We're going to write the elements next to each other. And then because one is a metal and one is a nonmetal, we know it's ionic, so we have to balance these charges. Lithium has a 1+ charge. Oxygen has a 2- charge. So we need to make sure this chemical formula is neutral. So lithium gets a 2. So our result is lithium oxide like this. And then to balance the equation overall, we have 2 oxygens here, but only 1 over here. So we need to put a 2 here. But this gives us 2 times 2 lithium, which is a total of 4. And now it's balanced.